Hello. Hello, wherever you are in any part of the world. Hello from my heart to yours. Europe, the global window of higher education. Scientists warn of nanotechnology threat. March the 1st, 2009. European scientists are starting to identify tangible health concerns associated with the use of nanoparticles in consumer products. Academic health experts expect within the European Union's scientific community on emerging and newly identified health risks have raised some serious problems in a new detailed paper. It represents a hardening of concerns. While the committee has previously highlighted the lack of knowledge about how nanoparticles could migrate from clothing and their dyes in consumers' bodies, it is now raising tangible fears. The committee's chair is Professor Jim Bridges of Britain University of Surrey, and its vice chair is Dr. Wim de Jong, toxicological pathologist in the Laboratory of Pathology and Immunobiology at the Netherlands National Institute of Public Health and Environment. In particular, the committee has focused on a common type of nanoparticle called nanotubes, noting that when they have similar characteristics as some type of hazardous asbestos, similar inflammatory reactions can be induced by the nanotubes as asbestos. This threat is serious because a wide range of industries, from food packagers to pharmaceutical companies, textile manufacturers, and paint makers, have been examining the potential benefits of using tiny nanoparticles to improve the quality and physical characteristics of their products. Research in this area has been booming, and the commercial spin-offs could be very profitable. However, the fly in the ointment is health. As with genetically modified plants, there are potential health concerns and a very real risk that consumer fears could stymie the development of products using nanoparticles. For the committee, however, it is the science that counts. It notes that nanotubes, a common form of nanoparticle, could be manufactured into long, thin, fibrous forms, length 20 micrometer, rigidity and non-degradability, in which case they would really resemble asbestos fibers. If these were then inhaled, say in a factory, manufacturing or processing nanoparticles, then a risk of mesothelioma, the cancer usually caused by asbestos, cannot be excluded. The committee paper noted, it has also raised concerns about nanosilver, which has been developed for use in biocide in products such as self-cleaning socks. Here, the report highlighted a toxicity study where an accumulation of silver was observed in all organs examined, that is, the blood, the brain, the kidneys, liver, lungs, stomach, and testes. Scientists turn atmospheric carbon dioxide into nanofibers. August the 20th, 2015. A group of researchers led by Dr. Stuart Litch of George Washington University have developed a novel method to economically convert atmospheric carbon dioxide directly into highly valued carbon nanofibers. We have found a way to use the atmospheric carbon dioxide to produce high-yield carbon nanofibers. Such as nanofibers are used to make strong carbon composites, such as those used in the Boeing 787 Dreamliner, as well as high-end sports engines equipment, which wind turbines, and a host of other products. Because of its efficiency, the new process can be run using only a few volts of electricity, sunlight, and a whole lot of carbon dioxide. At its root, system uses electrolytic synthesis to make the nanofibers. The scientists estimate electrical energy costs of this solar thermal electrochemical process to be around 1,000 per ton of carbon nanofiber. Carbon nanofiber growth can occur at less than 1 volt at 1,380 degrees Fahrenheit. 750 degrees Celsius, which, for example, is much less than the 3 to 5 volts used for 1,832 degrees Fahrenheit, 1,000 degrees Celsius industrial formation of aluminum. We calculate that with a physical area less than 10% the size of the Sahara Desert, our process can remove enough carbon dioxide to decrease the atmospheric levels to those of the pre-industrial revolution within 10 years. August the 20th, 2015. Aliens. Alien Reckoning, Washington Post, April the 17th, 1994. MIT physicist David Pritchard, who has also been analyzing an implant that came from a man's penis, has written about the criteria for examining and determining the nature of such objects. I have myself studied a half-inch to 3/4 inch thin, wiry object that was given to me by one of my clients, a 24-year-old woman, after it came out of her nose following an abduction experience. Elemental analysis and electronic microscopic photography revealed an interesting twisted fiber consisting of carbon, silicon, and oxygen, no nitrogen, and traces of other elements. A carbon isotopic analysis was not remarkable. A nuclear biologist colleague said the specimen was not a naturally occurring biological subject, but could be a manufactured fiber of some sort. It seemed difficult how to proceed further. Edinburgh's drawings of Magellan's fibers. Magellan's disease. Have a wonderful rest of your day.